class we learned about matrix multiplication. We have also done about the properties of matrix multiplication and addition. Now we would take up some questions from matrix multiplication, that is from exercise 3.2. I am taking question number 15. Before doing question 15, there is something that I want to ask you. If I have a matrix A as 1, 2, 3 and 4, I tell you to find A square. So now when you find A square, simple one, square it up. It is what? 1, 4, 9 and 16. This is an obvious answer that all of you would give me. But I am sorry, this is wrong. Why? A square is A into A. It is matrix A multiplied by matrix A. It is not the square of every element. That means it would be 1, 2, 3, 4 into 1, 2, 3, 4. You will have to perform normal matrix multiplication to get A square. Same way, if you want to find out A cube, that would be A square into A. So whatever you have got A square from here, you would again multiply it with A matrix. That is how you find out A square and A cube. So now let's take up a question. Question 15, exercise 3.2 is what I am taking up. You're supposed to find A square minus 5A plus 6i. You're supposed to find A square minus 5A plus 6i, where A is given to me as 2, 0, 1, 2, 1 and 3. 1 minus 1 and 0. This is what is my A matrix that I have. So I have to find out A square. Now, as I told you earlier, how do we find out A square? It is what? A into A. So 2, 0, 1, 2, 1, 3. I write the same matrices in front of each other. Till you write them in front of each other, you cannot perform matrix multiplication. So please do remember, you need is what? A into A. So I've written matrix A 2 0 1 2 1 3 1 minus 1 0 with 2 0 1 2 1 3 1 minus 1 and 0. I've written both the matrices in front of each other. Now I perform normal matrix multiplication. I hope all of you know how we perform matrix multiplication. First row into the entire first column gives me what? The first element. So what would I do? 2 into 2 plus 0 into 2 plus 1 into 1. Same ways, now what? 2 into 0 plus 0 into 1 plus 1 into minus 1. Now what? First row, third column. So 2 into 1 plus 0 into 3 plus 1 into 0. Now second row, first column. So 2 into 2 plus 1 into 2 plus 3 into 1. Second row, first column is what I have performed. Now second row, second column. So this would give me what? 2 into 0 plus 1 into 1 plus 3 into minus 1. Second row, third column. So 2 into 1 plus 1 into 3 plus 3 into 0. Same ways, third row, first column. Now second row, second column. Now second row, third column. Minus 1 into 3 plus 0 into 0. So after performing normal matrix multiplication, what is A square that I get from here? I get A square as 5 minus 1, 2. 9 minus 2, 5. 0 minus 1 and minus 2. You can check on your calculations over here. So this is 2 into 2, 4 plus 6 plus 3. So I've got it as 9 here. This is what? Minus 1 and here this is what 1 minus 3, so that gives me minus 2. So that is a square that I have performed, but that's not the question. I need to do what? A squared minus 5a plus 6i. You remember what is I? I was the identity matrix. So you will have to take an identity matrix of 3 cross 3 itself. So let's do a square minus 5a. A square minus 5a plus 6i. So I write down a square from there. So it is 5 minus 1, 2. Minus 5a. So that means this A matrix gets multiplied with 5. So this would become what? 10, 0, 5. 10, 5, 15. 5 minus 5 and 0. The full matrix gets multiplied with the element 5. That is scalar multiplication. Plus 6i. 6i means what? 6 into 1, 0, 0, 0, 1, 0. 0, 0, 1. You will have to take an identity matrix of what order? You will have to take an identity matrix of order 3. That means I3. So now 6i. So this 6 goes inside. So this becomes what? 6, 6 and 6. Now perform your normal addition, subtraction. Please do remember to follow your board master rules. So what's the answer that I get from here? 1 minus 1, 3 minus 3. Minus 1, minus 1, minus 10, minus 5, 4 and 4. Normal addition and subtraction is what I have performed. See here, 5 minus 10 gives me what? Minus 5 plus 6. So that gives me what? Plus 1. Minus 1 plus 0 plus 0. So that gives me minus 1. 2 minus 5 plus 0. So minus 3. So that is how I have performed my normal matrix addition and subtraction over here. This is my final answer that I should get. So this was question 15 from the exercise. Another question on matrix multiplication. This is exercise 3.2, question 13 that we are taking over here. Now here a matrix is given to me, cos x minus sin x 0. This is given, and here it is written as fx. Fx means that this matrix is a function of x variable. So it is a matrix which is given in the form of a function. So fx is my function. Now what am I supposed to show? I am supposed to show that fx into fy is equals to f of x plus y. That's my question over here. So I start with the LHS first. I need to do fx into fy. So fx would be what? The full matrix cos x minus sin x 0, sin x cos x 0, 0, 0 and 1 into fy. Now what would fy be? I told you this matrix is a function of x variable. So fy becomes what? A function of y variable. So wherever x is coming, I will replace it with what? Y. So this would become what? Cos x. Sorry, this would become cos y minus sin y 0. Sin y cos y 0, 0, 0 and 1. I repeat, this was what? Fx into fy. So fx was already given to me. Now fy would become what? A function of y. So wherever x is coming, I will replace it with what? With y. Now I perform normal matrix multiplication. So first row into the entire first column would give me the first element. So let's see how we perform. Cos x into cos y. So cos x cos y minus sin x into sin y. So minus sin x sin y plus 0 into 0. So I am not writing that particular down. Now first row, second column. So cos x into minus sin y. So that gives me what? Minus cos x sin y. Then minus sin x into cos y. Plus 0 into 0. Now what? First row, third column. So cos x into 0 minus sin x into 0 plus 0 into second row, first column. So sin x cos y plus cos x sin y. Again what? Plus 0. Second row, second column. So that is what? Minus sin x sin y plus cos x cos y plus 0. Second row, third column. So sin x into 0 is again 0. So I got what? Again 0. Now third row, first column. So 0 into cos y gives me what? 0. 0 into sin y gives me what? 0. 1 into 0 gives me what? Nothing but 0. Third row, second column. So cos x into minus sin y again gives me what? 0. 0 into cos y gives me what? 0. 1 into 0 gives me what? 0. Now third row, third column. So that gives me what? 0 plus 0 plus 1 into 1 would give me 1. Please be careful. Do not write it as 0. Now let us apply our formulas. So if you remember class 11 trigonometry, we had these formulas. Cos x cos y minus sin x sin y was the formula for what? Cos of x plus y. So these are my trigonometry formulas of class 11. Please do remember cos a cos b minus sin a sin b gives me what? Cos of a plus b. So that is what I have applied. Now from these two terms, if I take out minus common, so this becomes what? Sin x cos y plus cos x sin y. So this gives me what? Minus of sin of x plus y. What have I done? I have taken out minus common. Then this is the formula for what? Sin a cos b plus cos a sin b, which gives me what? Sin of a plus b. So I have written it as minus of sin of x plus y. Then what do I get? 0. Then again the same formula, sin a cos b plus cos a sin b. That gives me what? Sin of a plus b. Sin of x plus y. Now here, if I write cos x cos y first and sin x sin y after that. So cos x cos y minus sin x sin y. So that again gives me what? Nothing but cos of x plus y. It's the same first formula. It is only inverted. 0, 0, 0 and 1. So this was what? The LHS of the question. I mark it as 1. Now let's take up the RHS of the question. What does the RHS of the question say? F of x plus y. So where there is x in place of that, what is coming? X plus y. So wherever I have x, I will replace it with what? X plus y. That means it becomes a function of x plus y. So it would become what? Cos x, cos of x plus y minus sine of x plus y, 0. Sine of x plus y, cos of x plus y, 0, 0, 0 and 1. I mark this as 2. So from 1 and 2, what can I say? LHS is equal to RHS. Please do not say directly from here. Please do mention the RHS and then say from 1 and 2, what do I get? LHS is equal to RHS. So what I have to prove? I have proved that particular question.